Alright, now we're doing 7Q numbers with digits inside. This is by user 5036852, and 86% of the people like it. We have to search all numbers from inclusive 1 to inclusive a given number x that have the given digit d in it. The value of d will always be 0 through 9. The value of x will always be greater than 0. We have to return as an array the count of these numbers, their sum, and their product. For example, x equals 11, d equals 1. So the numbers between 1 and 11 with the digit 1 in it are, there's 3 of them. So 1, 10, and 11 are the numbers with 1 in them. And the sum of them is going to be 22, so 10 plus 1 is 11, plus 11, 22, and so 10 times 11 is 110, and whatever that is times 1 is the same number. So that's what we're doing. We're getting the count, the product, the sum and the product right there. All right. So to start off with, before we even do this, we're going to have a way to check if the digit is in the number we're checking, okay? The index or whatever, the number we're checking, like 1 through 9 or whatever, all right? So to do that, we're going to make a brand new function up here, and we're going to call it isDigit. So we're going to say function isDigit. All right, and it's going to take as arguments index and d, the same d as this one, and also when we're iterating through, it's going to take the index as well, just to let you know. So while index exists, all right, we're going to say if index remainder operator 10 equals d, and d is that number we're checking to see, like the 1 or whatever. If index divided by 10 remainder, if index remainder operator 10 equals d, what we're going to do is we're going to return true, because later down here, if it's true, we're going to add it to the count. All right, but also if it's like 10 divided by 10, the remainder will be 0 and not 1. So in that specific case, we're going to have to say if we're going to say index, and then we're going to say if index divided by 10, or, and this is the bitwise or, which I'll show you right now. The bitwise or operator returns a 1 in each position for which the corresponding bits of either or both operands are 1. So basically, in this case, what we're doing is like index divided by 10. So let's say it's like 21 divided by 10. Okay. So 21 divided by 10, and I'm making this be 0. And let's say 21 divided by 10 up here. 21 divided by 10. Okay. Oops. And now let's run it. So the answer is 2, because that's how the bitwise operator works. So now it's going to, now that it's 2, it's going to go back in and it's going to say, okay, it's still not cool. So then it's going to go back down here. It's going to say 2 divided by 10. And let me show you. 2 divided by 10. Run it. 0. And since 0 equals false, let me just say false here. Since 0 equals false, it's just going to go back up here and the index doesn't exist anymore. All right? So, yeah, that's basically how we check to see if the number's in there. Now we're going to get into the guts of the actual function. So we're going to start off by declaring some variables. We're going to say let count equal 0, and then we're going to say let sum equal 0, and then we're going to say let product equal 1, because if it was 0, the product would just end up being 0. So we got to multiply it by 1 to start off with. All right, so now we're going to do a for loop so we can iterate through the numbers 0 to whatever. Okay, so we're going to say let's first we're going to say for, and then we're going to say let index equals 0, and while index is less than or equal to x, okay, so while it's less than or equal to that number, this number here, we're going to say index plus plus, iterating through as usual. All right, now we're going to say if, now we're going to do the callback. We're going to call back this thing right here. We're going to say if is digit with index and d, okay, so it's going to take whatever index we're on and d and throw it up here, and if this comes back true, if it's returned true to us, we're going to say count plus plus, then we're going to say sum plus equals index, and then we're going to also say product times equals index, okay? And that looks like it would work if we were to right now say, what is it? Return count. What else was it? Count, sum, and product. Sum and product. But it's still not going to work because it's these right here. When it's 0, it returns the product as 1, and we can't be having that. We have to make it 0. So to do that, to fix that little case, we're going to say if numbers are greater than 0, we're going to say product. But else, so if they're not, we're going to say product equals 0. Not number, excuse me. Count equals 0. We're going to say product equals 0. So if the count is over 0, like if there's actually a count, we're just going to return whatever the product is. But if there's nothing in the count, we're just going to change that 1 into a 0. And now it should work. Let's test it out. No. That's really annoying. Okay. If. Did I put this in the right place? Probably not. Let's see. Let me take this, put it here. Let's see what happens. Yes, good, cool, okay. All right, so make sure this is not inside the for loop. This is outside of the for loop right there. And other than that, it's looking pretty decent. Let me bring this back, and this back, and this back. All right, cool. Now it looks cool. Test it out. Let's attempt it. All right, 6 milliseconds. Now we're going to do the concise syntax, and I don't know if this is going to be faster or not, but it's good to know a couple more things, because look at all the techniques. These are all the techniques we're going to use for the concise. We just had to use this for this one here. So let's do that. First things first, let's get rid of this stuff up here. We don't need that. We're going to change this to const. Numbers with digits inside equals x and d, and then we're going to have we don't need any of this stuff. We're going to have an arrow function, an arrow right there. And we're going to start on the next line anyway. So basically for this concise syntax, we're going to start off by saying, what are we going to start off by saying? We're going to start off by saying, in here, we're going to say array.length, array, we're just going to say array, no, we're going to say array, and then an arrow function, okay? And this is going to be the main function, but we're also going to, since we're doing concise syntax, we declare the variable for array after, we define array after we do the function that's associated with array. Now let me show you what that means, okay? So right here, we're going to say, or we're going to use the array constructor and say array x, okay? And the array constructor right here is basically, we just do that, we just put array and then the array length in the parentheses, and there we go, array x. And now we're going to say dot fill, because we've got to fill that array up that's x long with something, and we're going to fill it with true, okay, just to fill it with something. And the fill method basically just fills up however you want. If you do it like 6, it's a bunch of 6s. If you do it true, it's a bunch of trues, all right? And so that's what we're doing here. And now let's go to the next line, because this gets real tight real quick. All right. And then we're going to say dot map, and we're going to use the element here. And for the map function, we're going to say, excuse me, not just element, we're going to do element and the index. Element and index, okay? So we're going to start off by saying, nope, that's not what we're doing. We're going to start off by saying string. We're going to use the string constructor, which basically just turns anything that can be turned into a string into a string. And we're going to say string element plus index, okay? And that's just going to add up. That's just going to add up to see if this is going to work out for us. So let's go to the next line here. We're going to do a filter after this. We're going to filter this element to see if it can even belong in the array. So we're going to say dot filter. Bring it back here. Nope. We're going to say dot filter, and we're going to say element arrow, and if element dot includes the string constructor d, all right, if that's the case, we're gonna keep it, and then after that we're going to say dot map one more time, and we're going to make it to where the element is turned right back into a number. Okay, so number and element, all right? So let me go through this. Okay, so first we're making an array, and it's going to be x long, and then we're going to say whatever number we're on through the 1 through x. We're going to say string. We're going to say element plus index. So like, let's say it's, so the element is true, and then the index is going to be 0 to start with, and then 1, and then 2, and then 3, whatever. And we're going to turn it into a string in this one, and then we're going to see if if this string includes the number D the digit D that we're looking for. And if so, we're going to turn it back into a number and put it into a new array with map. And then that array is going to come up here with all the numbers that we got. And so up here, what we're going to do, I'll just start on a new line. We're going to do an array just like before. It's going to be, actually, while we're at it, I'm going to declare in here, what is it? What do I want this to be? Length equals array.length. All right. So we don't have to go and say array.length over and over again. So we're going to say, first we're going to say length in the first position. Then we're going to, that's for the count. Then we're going to say down here, we're going to say length. If length exists, we're going to say, because remember those zeros before, so if length exists, we're going to say array.reduce, and we're going to say previous, current, and then we're going to say, previous plus current, or we're going to say 0. All right. So if it exists, we're going to do a reduce for the sum, and if not, it's going to be 0. And then we're going to also do another comma because we're doing the third thing, which is the product. So we're going to do pretty much exactly the same thing here. Might as well take this whole thing, drop this in here nicely. All right. And instead of previous plus cur, we're doing previous times cur. And that should do it. And it did, look. 4 milliseconds versus, how fast was the other one? 6 milliseconds. Look at this. This block, this bulky block is the winner. All right. So let's submit it. All right. I very much like this one. Oh, look, I got Codewars, whatever. My solutions, just me. Best practice in my opinion. And we'll see you next time.